while we're here, I mean, we also have to do some kind of follow-up meeting on the CDS that we had. That's Crimson Orchestrator. We have the Orchestrator Quincy as a pet that we have to convert into some kind of a roadmap. I would propose to use next week's Orchestrator meeting for that, and not schedule another slot for that. I think we're good.
Yeah, I think so. That seems fine.
Okay. So what do we have? We have what topics? LGW keyring is the first one. Who added that?
I added
Mike.
it.
Rasha and Mike. Glad you are both here. Okay. The thing is, we have the LGW keyring deployed by Ceph ADM, and the LGW fuzar block also being deployed in the Ganesha conf deployed by Ceph ADM. I think it works, right? It works as it is right now. It's a bit weird that we are deploying the LGW keyring, even if no one is ever going to use that LGW NFS backend for that particular NFS daemon.
It works fine.
It works.
Yeah.
But I don't know if that's how we want to do that. Basha, Mike.
Oh wait, didn't we also decide that if you have a duplicate block, then it'll use the first or last one, and so we could
The
just
first
have
one.
the RGW keyring block in every single RGW export Rados object fragment.
But we need to physically deploy the LGW keyring. No?
Oh.
Yes.
Oh.
Yes.
Oh.
It has to remain in it's a volume mount to the container. The tricky part.
It's a volume in the container.
It's a volume mount, yeah. The keyring file.
Oh, I think we should just do it.
Some of them are weird. I think the CephFS exports, you can actually specify the secret, I believe. Is that right, Varsha?
Yes, we can specify the secret.
Yeah, we should do that. So that's a Ganesha change. Well, okay. So in the short term, if we just do what we're doing now, where we unconditionally deploy the keyring and have that block in the main daemon, that works. But then moving forward, we can modify Ganesha so that we can have a config option that specifies the key explicitly in the config without having to actually write a file. Then we can just have that duplicate that block for every export, or even have different ones for every export if that was what we wanted to do later.
And remind me, this is to address the rook use case. Is that right? Because we have a cap there. Or what was our motivation?
It's also a way to avoid deploying the LGW keyring physically on the host, right? Which would make it possible for us to not put the LGW block into the deployed Ganesha conf. Am I wrong? Yes?
Yeah, that's right.
That's right. Okay. So by putting the secret into Rados or into a config object, config setting, we can avoid polluting the deployed Ganesha conf with LGW. And still have all the flexibility that we have right now.
Yeah.
Mike?
was just thinking like it's going to take a while for that to trickle down from Ganesha, right? So if there's something we need to do short term for Rook, that's what I was kind of wondering. Not as familiar, but maybe not. Maybe it's okay.
I mean, I think we should just do whatever we need to do to make Rook work, however expedient and elegant it is.
And that's what I'm wondering. Are we going to end up doing the same thing that we did with Ceph ADM, but like, in Rook? Or is that even necessary?
What's the same what?
Doing the similar type implementation in Rook. So adding that RGW block to Ganesha comp for Rook. Or like, how is that working today?
Yeah. I mean, yeah, probably. I don't know. Yeah. They might as well do the same silly thing. It seems like the underlying problem is just that weird RGW block, the way it requires you to have a file, and there's only one of them, and whatever. Yeah.
Mm-hmm.
Well, we already have a key or a credential for Ganesha to access the Rados comps. Why don't we just reuse that for RGW as an intermediate solution?
If yeah, I don't know what the caps are on that, but if we can combine them into one credential, we could do that too.
Is it what Rook is doing right now? One keyring for both accessing the Rados confs and RGW?
Rook is using the client admin keyring. So.
Yeah, I think that's we didn't really specify that as a goal of what we're doing here is to stop using the admin key for Ganesha and Rook.
I guess if our long-term goal fixes this sort of completely, I'm not sure that there's that big of a ROI on sort of an intermediate goal. But I would be inclined to do the minimum needed to just get Rook working until Ganesha is changed. So like do the right thing and not worry so much about. But whatever. I think whatever the Rook people want to do.
Yeah.
Whatever makes it
go. I think we need to have a discussion with the Ganesha folks because right now they have like 4 or 5 different keys depending on what you're doing with Ganesha. And the artist has become a bit frustrating, and in some situations you can specify the secret, and others you have to specify the credential and it has to look up the keyring file.
Exactly. Yep.
Bit of a hodgepodge mess.
Okay, if we do not want the intermediate thing, then we can just switch over from the deployed RGW keyring into a Rados object or into a Rados secret, or I don't know, and then just drop the RGW parts in Ceph ADM as soon as Ganesha is ready.
Yep.
Does it sound like a plan?
Yep.
And then I guess all the keyring management would be done in Williams module. Is that right? We wouldn't want Ceph ADM to be doing that anymore.
Yeah,
I think there would always be at least one credential that FADM is managing, and that would be for accessing Rados itself to get the configs.
Yeah. Yeah.
Yeah. But we don't need to manage the RGW keyring then from Ceph ADM. That's then taken over by NFS module.
Okay. And then you're going to duplicate it in every export. But I think the other thing with the Ganesha folks you might want to discuss is the first parse block is the one that's retained. So each subsequent one doesn't
if we're changing the syntax, like the way that the CephFS exports work, if I remember correctly, it's just whatever it's in the export block itself, what key to use. Mm-hmm. We could do the same thing for the RGW export block, so that also it's there instead of in a separate block. And so there wouldn't be an RGW block at all, basically. That's probably the cleanest thing.
That makes sense. Yeah, I like that. And then you can block list them per export or something like that, right?
Yeah.
Sounds good to me. Does it sound good to everyone else?
Yes.
Perfect. Problem solved. Or problem not solved, but we have a plan. Next topic. Clients. So the problem is, the clients require the etc ceph.conf when talking to Rados, right? But Ceph-ADM is in control of the monitor daemons, which means that if we are stopping a daemon, if we are stopping a monitor, or if we're deploying a new monitor, or if we're migrating a monitor from one host to another host by creating another monitor on a different host, then we need to update the ceph.conf on all the hosts in the cluster. And we have to do that also for client nodes that mount RBDs or CephFS, which makes those hosts kind of part of the cluster itself. So clients that directly talk to the monitors are, when it comes to Ceph-ADM, part of the cluster, because Ceph-ADM needs to write the ceph.conf on the host. The problem clear to everyone?
Yep.
That's different when we are talking about iSCSI or NFS, right? The clients that connect to iSCSI or NFS just only need to know the gateways, but don't need to know how to access the monitors. Paige, you wrote something into the minutes.
Yeah, so the suggestion that you mentioned earlier was currently this is just a true-false, whether we update the ceph.conf and etc on every host in the cluster. We could change that to be a placement spec, so you could control which nodes that ceph.conf goes to. Another option could be that you could have it'll remain a Boolean, but so it'd go on every host in the cluster, but you could add a label that makes it not put it on a particular host. Or you could have a label that says only put it on this host and not the others. My sense is that maybe a combination of 1 and 2 should like kill the most birds with the fewest stones. But because that, yeah, I don't know.
1 should be enough for everything.
Yeah.
I mean, if we are making a placement spec, then you can either specify the host manually, or you're making a glob pattern, or you're making a user-defined label. And at that point, we don't need any special labels. So 1 is enough for everything.
So the question is, right now there's an option that is Boolean to turn it on and off. Should there be a separate option that's the spec that goes with it? Or should we change that option from Boolean to be a blank string so that it's opt in?
Just change it.
Yeah, okay.
Or, I mean, why making it another option?
Okay. All right.
We just need to make it legacy aware, right? Just
yeah,
fast forward and true differently.
Yeah. Okay. So true would remap to a star and false would remap to a blank string.
Yeah.
One question. And what about to deploy the ceph.conf in all the hosts that are included in the cluster, and to have a special type of host that is client where we cannot deploy dynamos? Because maybe I don't know, but it's probable that for clients we will need to distribute key rings or to create any kind of structure. I don't know, but
key rings. We already have that problem, right? The keyring. We are talking about two different keyrings. The client are probably going to need a special client keyring. Maybe even if you have two different kinds of clients, one keyring just mounts Ceph and the other set of clients mount RBDs, then we are probably going to need two different keyrings for the clients. Another problem is that that we are only having the admin keyring on the Bootstrap host. So Ceph ADM does not deploy the admin keyring on other hosts. So if you're losing the Bootstrap node of a cluster, then you're going to have problems accessing the cluster because the admin keyring is only located on the Bootstrap node. So which means that we should probably add a feature to also deploy the admin keyring on other monitor nodes. And by that point, we are already dealing with different keyrings on different hosts. I mean, from a data structure, it's easy, right? You can just say a key value pair, deploy this keyring on a host on hosts that match this placement spec, right? Deploy the admin keyring on hosts that have the admin the monitor label, or deploy this kind of client keyring to hosts that have a client label. I don't know. I'm a bit hesitant to implement some kind of special client host because it would introduce some kind of a new concept, and I would like to avoid that. Just a gut feeling.
New concept about kind of host. Is what you mean or not?
Yeah, I would like to avoid it.
Okay, but you are going to avoid that, and you are going to make that the users need to know better how works Ceph internally. Okay, it's more easy to say this host is going to be a client, and I don't know what is going to happen with that host. But the thing that the only thing that I need to know is that we are going to it's going to be possible to access to the Ceph cluster from that host. Okay. That to explain that what kind of key ring do you want to copy in each host or in what host? I think that is more difficult to understand, that you need to copy the Ceph-conf, that you need to copy different key ring depending of the things that you are going to need to do. I think that is more easy just to say these are client hosts, and you will be able to access OSDs from this host, and this is going to be an admin host, and you are going to be able, for example, to launch a Ceph shell in that host. I think that is more easy to understand. You are introducing a new concept because we are going to have different kind of hosts, but I think that is more easy to understand for everybody.
I think the problem with that is that if you look at this next section where we want to deploy these keys, then it's not just admin hosts and client hosts, because they're different keys that should be distributed to different hosts, right? So like probably there'll be a set of hosts that need the RBD key to access the RBD pool, and there'll be certain different hosts that need a different key to access the CephFS file system or whatever it is. And so it's not, I think it needs to be flexible so that they can have any label and any key. We could default to have a label called admin that we apply to a bunch of some of the initial hosts. I don't know if we can figure out which ones that it would do that for, but I don't know.
Well, to use labels could be possible, okay, but I think that is not a very strong setting, okay? Because can be, well, it's very easy to set the wrong label just because you are typing the things with an error, okay? So I think that is more, it's not very strong, but it's a possibility, yes.
I mean, we can provide a new CLI for it, right? We can say Ceph ADM add client host, right? And then provide the need CLI for it. But I would like to avoid introducing some kind of client host within Ceph ADM itself. Because there is so much identical to client host and the rest of the hosts.
Yeah, and they'll overlap. Like I think on any Converge cluster, then they're the same.
Yeah.
I don't know. I mean, the only thing that distinguishes a client host is that we don't put cluster services there. It's a no schedule flag.
Yeah.
So I think it's just clearly documenting that you add them with Ceph orch host add foo no sched or whatever it is. Because you can specify labels on the command line.
I was wondering because in the dashboard we had a discussion on well, kind of a wizard or a helper for providing the Ceph-conf and also downloading the keyrings for clients. It was a very early discussion we had a while ago, and I was thinking, is it possible maybe to read the Ceph-conf from a web server and same for the keyrings, kind of servicing that from a single location? Could that solve part of this issue? Because part of the approach that we were thinking on was more or less like that, providing users with an endpoint where they could download their kind of Ceph.conf and also the keyrings based on their permissions.
Doesn't work. Doesn't work because if Ceph ADM migrates a monitor to a different host, and Ceph ADM is deploying a new Ceph.conf on all the hosts to avoid timeouts. If you are dealing with an outdated Ceph.conf on a host, then you're prone to timeouts when connecting to the cluster.
Yeah, but if you're reading from a remote Ceph.conf, you will always have the latest version, right? So you don't really have to take care of the local copy of that.
Yeah, but it doesn't solve anything because you need to know the location of the remote Ceph.conf.
Yeah, well, but that could be a single location, let's say, rather than migrating services like monitors or.
You would need to do that behind a load balancer with a keep alive D in order to be high available.
Yeah.
And we already can deploy the Ceph.conf to all the daemons because we have to do that anyway. So we already have the code to do that. We just need to extend it to the client host. I mean, they're not really clients because they're part of the cluster, but to the clients that directly connect to the OSDs and to the cluster. We already have that. Ernesto.
Yeah. Sorry. Yeah. Thanks.
Okay. So what about some kind of a convenience wrapper? Ceph ADM client-host add that makes it easy to add a new client host. I think it's optional and I think it's super trivial, but it would complicate the CLI a bit. I'm torn. I don't know.
I guess
Might
I would
make
be
sense.
inclined to do the other pieces first, and then if it's 3 steps, and which should really be 1 step, then we can add the wrapper.
Yep.
Okay.
Oh, you already created a no-shed label. Oh, you're fast.
It wasn't as complicated as I thought. I think the real question is what to name it. As always. Right now it's no shed. It could be no schedule. Demons. Be conf only. I don't know. I think no shed or no schedule. Or no shed. No shed is what it is right now, which sort of is similar to the very terse flags that are in Ceph, but it's not super friendly. The other thing that strikes me is that this idea of scheduling, meaning the process of putting daemons on hosts, is kind of like a Kubernetes-y way of talking about it. I don't know how general that term is. I would have called it no deploy or something, or no daemons. I don't know. I'm not a big fan of the FADM thing in front because it's super verbose, and I think the underscore sort of already indicates that. But
I like the shed or schedule more than daemons or deploy.
I think that's fine. That one?
Yeah.
I think this one's my favorite.
And what about client?
We need that host. We need that label as well. If you're removing a host from an existing cluster, then we have to do many things, right? One thing is we have to prevent to deploy any new daemons on that host. So we have to add the no schedule label to that host. In addition, we also have to drain the host of existing daemons. So we also are going to need some kind of underscore drain label to that host.
Well, so the way that this works, if you set no schedule, it drains the daemons. Because we just don't place things there, and so the next time the loop runs, it'll move them somewhere else.
Oh, perfect. So we already implemented drain. Great.
Except that it doesn't drain OSDs. Because OSDs aren't scheduled in the same way. It does. I did make it so that we won't place OSDs, but when we apply the drive specs, it skips these hosts, but it doesn't remove them. So I think that's the last piece.
Should we add later some kind of underscore drain OSD label? Or just reuse no? I'm a bit hesitant to use no schedule to drain OSDs because
me too.
I have the feeling that we have to be super explicit when draining OSDs.
Yeah. I think a drain OSD flag is probably
a
convenient way to do it, but I would defer that until we do the drain implementation to see if labels are actually the right thing to do.
But you can already do that, right? You can say underscore no schedule to the host, and in addition, just manually drain the OSDs, and then you end up with a host without any daemons.
Yep.
And then you can remove the host.
Yeah. This would be enough to have a fully documented working process to.
Wow, that's great. That's super awesome. Ceph host add label again a Ceph ort OSP RM,
Oh yeah. Yep.
and then 3 is Ceph ort
Host RM.
host RM. Omega, what do you think?
I think that, well, very happy with this. It simplifies a lot. For example, now we have a problem in performance that is about cleaning environments, okay? And people is doing that manually and is forgetting to clean parts, okay? So to have this is going to make more easy all these kind of things, okay?
All right. I will leave that as a separate PR. I think doing that documentation, but not included in the no-scud one, but I'll update it with this new naming.
That's a
And then
follow-up
probably
thing.
start working on the keys thing and the placement spec. I guess each of these are action items. Okay.
Okay. NFSHA.
Okay. So there's this pad. I started just writing down all the different ways this will work to think through them all. The underlying constraint is the important part. It's that each Ganesha has an ID associated with, that's its rank, that's its role in the cluster, and there can only be one daemon using a rank at a time, or there should only be one daemon using a rank at a time. And the rank is sort of logically how it tracks the client leases and delegations. So if the server restarts and the client is reconnected, it needs to reconnect to the same rank or else we break the NFS protocol. So generally, if whoever an NFS client is mounting, it always has to go to the same rank. But we can make as many as you want. So option 1 is what we talked before about combining a single image with keep alive D and Ganesha. And so that keep alive D has the virtual IP on one host, and whoever has the virtual IP, we start up the Ganesha. And if we deconfigure the IP, we stop Ganesha and then start it wherever the IP is. And so there's if you have a spread across 3 hosts, only one of them runs at a time. This is super gross because we need to have a combined image with keep alive D and Ganesha and all these annoying hooks. The hooks don't look like they're really intended to start and stop services, and so it's a little bit janky. I don't know. I don't want to do that. Ceph option 2. I guess the benefit of option 1 is that it's fast, right? So as fast as keep alive D is doing its health checks or whatever, is as fast as we'll get failover. Option 2 is just let Ceph ADM do the restarting, similar to what Kubernetes does with Rook. So if there's a single virtual IP associated with the Ganesha, we only place one of them. If that host goes down or whatever, we just let the Ceph ADM scheduler say, oh, I'll create it somewhere else, similar to what Kubernetes would do. The downside there is that the reconciliation loop with Ceph ADM is currently very slow. I think over time that'll get faster once we have an agent and whatever, make other improvements. So I think that's sort of an orthogonal problem. And the other thing is that we don't really have a liveness check. Ceph ADM knows that the daemon is running, but with Ceph ADM doesn't have any concept of is the daemon working? And so basically all we're doing is seeing whether the systemd unit is in the running state or not, which might be good enough in the short term, but maybe in the future we'll want to add a liveness check. But I think those are sort of orthogonal problems. The thing that's sort of a problem here is that there's what the net of this is that there's sort of a virtual IP that's associated with the NFS service, which is a little bit weird. Which means that Ceph ADM would basically saying when this service starts, it adds that IP, and when it stops, it removes the IP, which is something that it hasn't done before. But it would work, I guess, to some degree. And there'd just be probably some limitation or something that basically prevents Ceph ADM from ever having a placement that has N of these, because that's sort of nonsense. I tried to two ways, sort of extending this idea to have like multiple for scale out. You can mostly ignore it. It's basically just a list of virtual IPs. But I don't think it's a very good option. Option 3 is where I ended up yesterday, though I think this kind of captures most of both worlds. The assumption is that the next step after this is that we'll have the ingress service with HA proxy pointing at these. And so option 3 sort of combines both of those together. So the idea there is that instead of having the Ganesha ID either being the service name or the daemon ID, it's sort of a static rank like A, B, C, D, or 1, 2, 3, or whatever. And Ceph ADM, the service, is sort of responsible for dynamically allocating these to the daemons as they're created. So if it's like A, B, C, D, we always try to use like the lowest letters that are uniquely mapped to, nfs.hostname. Some gibberish or whatever would be A. If it's not already used, then there'd be a B. If A gets destroyed, when we create a new daemon, it gets allocated A. So this mapping is sort of maintained by Ceph ADM. So that gives us our sort of distinct, unique set of ranks that are a small number and predictable. Here again, we rely on Ceph ADM to like do the rescheduling. So if one of the Ganeshas goes away, then it'll create a new one, and it'll sort of, even though that's a new unique daemon with a new name, it gives it a rank. It gives that same rank A again if A went away. And then my initial proposal is we don't do anything magic with IPs in the NFS service. All it does is this rank thing so that it gives you nice ranks. And then we add support to ingress so that it will do an HA proxy that will bounce across them. And I looked at the HA proxy settings. There's one balance mode that basically hashes the source IP. And so it's deterministically will map you to a backend server. Then you can use consistent hashing so that when you add and remove servers, it sort of disrupts a minimum number of clients. And then the server lines would just list the rank as the ID. So it's a stable identifier as opposed to the daemon name. And because of the way that Ceph ADM already can like regenerate the HA proxy config if the backend services change, if Ceph ADM destroys or we lose one Ganesha and it creates a new one with the same rank somewhere else, the daemon ID will change even though the rank has it, and that will trigger an HA proxy reconfig, which will change the server line to have the new IP with the same rank. And so those clients will get redirected magically as part of that. So I think my only question is, what happens if a server is down? If we have a down server, but we're using this balance type source, will it just deny those clients any connection, which I think is what we want, or will it like hand them to a different one? So we need to make sure that it can actually do that. So a little more testing to do there, but I think this is, my sense is that this is the one that sort of gets the best of both worlds and sort of logically keeps things as simple as possible. What do you guys?
And option 3 also uses the reconciliation loop of Ceph ADM to deploy new daemons with the same rank.
Yeah, exactly.
I kind of like that. Because if we find a solution to increase the performance or the
responsiveness of the reconciliation. Yeah, exactly.
Responsiveness of the reconciliation, we are solving many problems at once. We are solving the problems of a slow reconciliation loop for larger clusters.
MDS standbys, moving the managers,
MDS
all of that stuff. Yeah.
Yeah, we are solving so many issues if we are having a fast response to failed hosts, failed daemons, that I would like to avoid having some kind of different, unique approach just for NFS-HA.
The other thing I like about it is that the ingress, assuming that in Kubernetes we can induce the ingress router, whatever controller thing to configure HA proxy in a similar way that will actually not break NFS, then it's basically the same structure in both cases. Like Ceph ADM is doing the same thing that Kubelet is doing by just creating these daemons when they go away, recreating them when they go away, and the load balancer is doing the same, has the same behavior also.
Yeah.
So I like that symmetry. There are a bunch of little corner cases, like this thing that I mentioned, what happens if a server is down? Are the clients rerouted? We need to make sure HA proxy can be told not to do that. It'll like basically fail those guys until the backend server comes back. I'm not sure if it'll do that or not, but hopefully it will. And like if we scale NFS up or down, then the ranks change. But we need to make sure like a transient change in those backend servers doesn't break things. So like if one of the daemons goes away and we have to create a new one, maybe HA proxy gets reconfigured in that interim middle period and the server count changes, and we don't want that to happen either. We want to somehow. Anyway, I think these are solvable problems.
Yeah. Did you talk to Ceph? Clayton?
Not yet. I talked to him 2 weeks ago or last week or whatever it was, which is to get sort of an understanding of the Ganesha behavior. I have one question I need to double check with him, and that is if like if a host goes down that has rank A and you recreate a rank A somewhere else, so then it's running, and then host comes back up and that rank A daemon starts but doesn't have any traffic on it, and then Ceph ADM notices and kills it, is it going to disrupt anything? I'm guessing that the worst it'll do is like trigger a reclaim grace period, but since no clients are actually accessing it, I don't think it'll disrupt recovery, but I need to double check that's really the case.
Well, that's one of the things I was going to ask. Are the ranks pinned to a host? Or no?
No, they float.
They float. Okay.
Yeah, so that's the main change. And it's actually the fact that they float that makes it work, because if they float to a new host, then they'll have a new backend IP. In the HA proxy thing, the server line will change. So that's HA proxy mapping those. That becomes the virtualization essentially, is that HA proxy config update that's mapping the logical rank to whatever IP it happens to be on.
Gotcha. Okay. Is a port part of that so that we can actually co-locate?
It could be, yeah.
Okay.
Yeah.
Cool.
Yeah, the Ceph ADM innards that do this like port exposure mapping stuff handle all the ports sort of on their own. So the only sort of usability gotcha in here is that you want to make sure that the NFS service probably runs on the non-standard port, so that if it happens to be running on the same nodes as the ingress controller, which is probably running on the actual NFS port, they don't conflict. So we might want to adjust, or at least clearly document that the NFS server should be on a custom internal port number or whatever if you're using the ingress controller.
We might be able to just change our start port, right? Figure that out based on this configuration. Possibly.
Yeah. Yep.
Okay. So we just got a new topic. SQLite for Ceph ADM.
Yeah, I was just kind of wanted to pose an open question if there's any interest in using SQLite for storing the state of Ceph ADM. I got a PR up that is ported the device health module over to use SQLite, though it's no longer. It was using the config key store for the mons for storing the last scrape. The time it did the last scrape of all the OSDs. And now that uses a simple key value store in SQLite, and then also just the smart data itself is stored in SQLite. This PR is nearly done. So I'm hunting for other use cases for storing state by manager modules, and Ceph ADM came to mind.
Yes, we do have
there's
something.
Any interest.
Yes, we do have something. And that's the event that we are storing per daemon or per host, or per service. So we're doing, if you're running something like Ceph Orch ls YAML or Ceph Orch ps, then we are returning events like then at some point we've deployed a service, we've deployed a daemon. If the deployment failed, we are associating the failure reason to the specific daemon. So it's really super helpful, right? To debug, but it's only in memory and it's getting lost when we are failing over the manager. So having that in Rados would be super helpful. But we have to avoid getting we have to avoid any deadlocks, which means that Ceph ADM needs to be fully functional, even if we do not have enough OSDs running. So Ceph ADM needs to always be able to deploy new OSDs. So it must not hang on Rados writes.
Yeah, so what I would suggest as a possibility is we could have a SQLite database in memory that the Ceph ADM manipulates, and then periodically backs that up to uses SQLite backup API to send that off to Rados periodically. And so at least the main thread would never be blocked on a Rados reader, right?
Yeah.
That would give you the ability to store a lot more information, debugging, event changes on hosts. I could see a lot of opportunity there for improving our debugging and introspection. But yeah, then the reconcile loop would never be blocked on the Rados ops.
My sense is that currently these events are like pretty high level events. Like we aren't generating a lot of them. I wonder if it's worth the effort.
So the problem, we're losing them when we are doing a failover.
I mean, maybe we should just store the events in a different place, like just store them in a separate part of the config key namespace. Like I think, are they part of the spec right now? Like they're embedded in this spec store?
No, they're not in the spec, so they are part of. Yeah, they're a different class in the Fedem inventory.py.
Yeah.
It used to be written to config key, but Neha was really skeptical and advised against writing them down.
I mean, they're written to the log. I don't know.
Yeah,
like,
no one reads the log in case something failed, except for if you really have to.
I mean, the whenever I'm doing anything with Ceph ADM, I always have a terminal with Ceph-W Ceph ADM to watch the Ceph ADM log go by.
Yeah.
It feels like the event should be basically a structured version of that. And that, I mean, those logs go to the monitor, right? I don't know. I mean, it's the same level of frequency that like the cluster log triggers. So it doesn't seem like it's not a lot of storage. It's a little weird that we have both, I guess, duplicating.
So at least in my experience, if I recommend looking at those events, it was always super helpful. Yeah. I think that you're a special case, right? When it comes to debugging Ceph ADM.
I mean, maybe I would suggest that like any phone calls, that any Ceph ADM user who's like should be in the habit of like, if they want to know what's going on with the cluster, they should just tail this part of the log, or the dashboard should show it. I'd actually really like to change the Ceph CLI command for watching the log to work more like journal control logs or whatever, so that there's a log last command that will show you the last few commands, but then there's also the watch, which is whatever, their sort of disjoint. It would be nice to just have like a a single command that sort of does both. That will tail and show you the last stand entries and whatever it is.
Anything? I think we're out of time.
Yeah.
And
Anyway,
we
something to
already
think
have.
about.
Yeah.
And we have the NVMe over Fabric books already turning.
Okay.
One last request. Would be great to have some more reviews for pull requests. Because I don't know how much time I can put in the reviews right now.
Yeah.
Okay. Thank you, everyone. And let's meet next week for the CDS follow-up. Bye.
Bye.
Hey, Brett.
Morning, everyone. This is Scott. I've got to take off in 10 minutes. I have a conflict, but I wanted to point you to, if you're interested, the second of the RBD BDev patches. This one is about the single cluster context. And I just typed it into the Etherpad. So other than that, I have nothing to report.
Okay, this is great news that is already ready. Since Jim last week said that no one is currently working on the namespace masking thing, I took the liberty and implemented a small prototype in SPDK to implement namespace masking.
Excellent.
I can go over it and also show a demo, but probably takes around 20 minutes. We can also do it next time if you want to be part of it, Scott.
I would like to see it. I wouldn't say wait. I could always bug you later, I suppose.
That also works fine with me.
Okay,
Yeah.
let's assume let's just proceed, and I will catch up with you later. How about that?
Okay. So if nobody else has anything, then I would go ahead and just explain how the whole thing works and what the thought process was. Hey, then let me share my screen. Can you see my screen?
Yes.
Yep.
Yeah.
Okay, good. Okay, so I put together a few slides because the first thing I looked into is basically, okay, you probably remember the discussion about subsystem versus namespaces. And this is just a slide I put out of this discussion, which is basically just what we discussed. What you want is essentially showing different kinds of namespaces at the initiator side, right? So here it would be namespace A is only shown for this initiator, and namespace B here is only shown for this initiator. Okay, so the first question for me was, does the spec even allow this? And so there is the sentence in the spec which basically says a NVMe subsystem is not required to have the same namespaces attached to all controllers, right? There are two things here that we need to understand. What is a controller and what does it mean for a namespace to be attached? On a high level point of view, for those who are familiar, this is just going to be boring, but bear with me. essentially the controller is the heart of the operation, where the interface between the host and the actual namespace, where all the commands are being executed and the completions are processed and so on. Okay, so if you remember, this is essentially how our multipathing thing would look like, right? But you can also imagine without multipathing, just as an example. Essentially, you connect to a controller, right? And the controller has some namespace behind it that access the RBD image, right? Okay, that's essentially it on that side. Now, there's two things in NVMe over Fabric Stack. There's a dynamic controller and a static controller model. And the SPDK currently only supports the dynamic controller model, and that's fine. That also fits with how I implemented this whole thing. And essentially, the idea of the dynamic controller model is that from the get-go, there is no controller allocated. The controllers are only allocated on demand when you connect to the subsystem. When an initiator connects the first time to the subsystem, basically the admin connection creates a new controller in SPDK. And that also means that each controller is basically associated with a specific host, and a host can have multiple controllers because it can have multiple initiators, right? Okay, so from there on, it basically then the controller view would look like that. If you have namespace masking, right, you have a controller that only exposes some of the namespaces within the subsystem. Very similar to what before, just that now we use the controller term here. Okay, then one other thing is that I haven't mentioned until now is I just named them A, B, C, and so on, right? These namespaces, but actually the namespaces typically have a namespace identifier in NVMe, right? And that goes from 1 upwards. Then how the namespace identifiers are actually assigned to the namespaces is not defined in the spec. That's basically, it's outside of the scope. That's fine, right? Could be random, but typically, of course, it's just 1, 2, 3, 4 consecutive. Now, the question for me was, do these namespace IDs have to be unique within the subsystem, or could different controllers have a different set of namespace IDs? If that's possible, but the spec is clear here. It basically says, if you use namespace management, ANA reporting, NVMe sets, or more generally, if you use shared namespaces, they should be unique within a subsystem. Which, at least in the multipath, we use shared namespaces. So let's assume they are unique, right? And that basically looks like this, right? You have two controllers. You have the same namespace ID attached to the same namespace behind it, where the actual data is. Okay, now let's talk about what does it mean to attach what does an active or inactive namespace ID entail? Is essentially you can attach a controller to a namespace. And if it's attached, then it's an active namespace ID. If it's not attached, then it's inactive. And what does it mean is you can only do IO to an active namespace ID. If you do IO to an inactive namespace ID, it will just abort the operation and it will give you an error, right? That's part of the spec. Spec. It says basically this is one-to-one out of the spec, specifying inactive namespace ID in a command that uses a namespace identifier field shall cause the controller to abort the command. That's it. And then there's one other thing is, in theory, you can list all the namespaces that are attached to controller or not attached. So inactive and active. But in the general sense, you only get a list, right? You don't, for an inactive namespace ID, you are not allowed to query capacity, size, or anything. And SPDK for now only supports to show all the active namespace IDs anyway. And I just saw that Scott pointed to the base spec, and that's true. What is shown in the base spec is essentially you can have private namespaces that have their own namespace identifier. This is basically about the uniqueness, right? For private namespaces, they are not required to be unique. So you could, in theory, have namespace identifiers that are not unique within the whole subsystem. That's possible. But as soon as they are shared, they, at least according to spec, should be unique. It's not clear, however, if that means that they should only be unique to the controllers that share those namespace, or if they should be unique globally in the subsystem. At least in how I read this here, for me, it says they should be unique within the subsystem globally. But I mean, that's debatable. Okay, so then how would namespace masking look like when you have active, inactive namespace IDs? Essentially looks like this, right? It's similar to the picture before, it's just that now you basically, in theory, yes, the subsystem or the initiator sees all the namespaces. Also, he cannot do anything with the inactive ones. He might be able to list them if this optional feature is supported. Otherwise, he doesn't even know that these exist. And this is essentially what I implemented in SPDK. Okay, so I have one slide in there. It basically also goes to what Scott said, is do we even care about the spec in this regard with the uniqueness of the namespace IDs and so on, right? Probably not. I mean, we don't have to adhere to that. I think from initiator point of view, it doesn't really matter. You can have a mapping that maps namespace IDs for each controller. The problem is, at least that I see, is that you create an unnecessary hassle, right? Then you don't have a subsystem end-to-end namespace identifier where you can uniquely say that identifies a particular image in your subsystem. This would always be local to a specific controller, which means you always have to update metadata. Okay, any questions so far to this? Okay, then let me go on to the actual implementation. So as I told you, so SPDK has a dynamic controller model, meaning every time you connect the first time with the admin queue per connection, a new controller is allocated in SPDK. And all state for this controller is hold as long as the connection is alive. As soon as you disconnect all the IO queue pairs and the admin queue, the controller is deallocated. Okay, what I did is essentially these 5 things, right? So to allow attaching and detaching controllers of a particular host to a namespace, since this is a dynamic controller model, we always know that a controller is always associated with a host indirectly, right? So what I did is I added RPCs to attach and detach controllers of hosts to namespaces via host NQN. And then basically this allows to attach and detach controllers to namespaces on the creation, and also during the lifetime of a controller, you can dynamically add and remove them. And for the dynamically attaching and detaching from a controller, I create async namespace events such that they are all directly reflected. Then for every command that uses namespace ID, I check if the namespace ID for this controller is active. If it's not, I abort with the correct message, right, according to the spec. And for the last one is if you do an identify active namespace list command, it basically only returns you the active namespace. The other, where you can enumerate all, is not implemented by SPDK at the moment anyway. Okay, so this just a bit, it's just 2 more slides, and I can show you a quick demo. This is how it internally looks like in SPDK. So each of these is essentially a object. So you have a controller object. As I said, it's basically always tied to a host NQN since it's dynamic controller model. It has a pointer to a subsystem. The subsystem and the namespaces are always persistent across controller objects, right? So they only get basically allocated once. And the subsystem has a pointer to or an array to namespaces in there. And essentially what I added is these 2 things. So now in the namespaces, there is a list of attached hosts. So this is basically controllers to attach to on creation. It goes through this list and attaches all these controllers to this namespace. And on the other hand, there's a bitmap here in the controller, which allows me to quickly query without going in this namespace list to see if what the namespace state is, meaning if it's active or inactive. So these 2 more or less denote the same thing. The left one is just for performance. So that you can basically quickly just with the namespace ID index figure out that if it's active or not and abort if it's inactive. Okay, any questions to this? Okay, then I can show you a small demo. Okay, so what I have here is let me start the target application here. So this is just an SPDK target. And then I have this little script which sets up a target. What it does, it creates a transport, creates a subsystem with this name, and then it creates as many BDEV memory devices as you specified, each 64 megabytes, not relevant for this test, and then it adds the namespace to the subsystem. In the end, it adds a listener to it, and in this case, the RDMA listener on this IP, this port. Let me set this up. Let's say we do 4 namespaces, and in SPDK they will be enumerated namespace 1, 2, 3, 4. Right? You can also see here that we now have a target listening on this IP. And now I have two different hosts here. So let me connect to it. So you see we connect to this target with this subsystem, and we use this host NQN to identify ourselves. 22 in the back matches with the host name. Okay, so I connected to it, and now we can do NVMe list, and you see there's nothing was added. It's the same 4 local devices that we had, because for now, for default, I don't attach any controllers to the namespace. And now what we can do is I added this new RPC, which is basically NVMF namespace attached controller. It takes the subsystem NQN, it takes a controller ID, it takes the namespace ID, and then you can specify which host NQN you want the controller from all these hosts to attach to it. And if we execute this and now do the listing, we see that we attached this namespace to the controller. Or the other way around, you attach a controller to a namespace, but you get the gist, right? And we can do the same thing from the other machine. This is now 19. And if we list it here, see, nothing has been attached yet. So we can do the attachment, but let's use a different one. Maybe the first namespace identifier. And if you list them now, if you look here closely, you see the namespace ID. We have namespace ID 1 here, and here we have namespace ID 3. So that's essentially it. Any comments, remarks, suggestions?
This is cool. Thanks for showing and doing the work. Thinking about paste notes to the people on the call with the specifics, though.
So,
Jonas, what is missing to push this on to SPDK, basically?
So what is missing is, I probably have to write some tests and some stuff like that. But other than that, I try to make it as clean as possible. Obviously, when I submitted them, let's see what the SPDK folks think about it. But other than that, it should be in theory ready to at least go through a review round.
Cool.
Yeah, that's essentially it from my side.
I maybe want to raise one point. We raised this internally with Jonas, but basically the list of what namespaces are allowed per each connector or each initiator is just kept internally in SPDK, so in the namespace. It would be really nice if we can hook this to the Ceph access control, namely the Ceph notion of namespaces, and have like a single point of who is allowed to access what. And I'm not clear if that is easy or very difficult to do, but one thing is, with Ceph, the notion of namespace, you can have a lot of volumes in a single namespace. With NVMe over Fabric, that's not the case. Namespace is a single volume. But if anyone has any ideas on this, on how this can be integrated, or can we integrate the gateway with the Ceph monitors to have a single point of access control, that would be good to hear.
Well, typically with other gateways, the Ceph access control is very coarse-grained. So the gateway itself has a CephX user or CephX entity, which it uses to talk to the cluster, and the outside access control, if you will, like in the RGW case, this would be the difference between the RGW CephX user, which it uses to speak to the Redis cluster, and all the S3 users that you can set up, and you can use various different schemes for doing that, or even entirely external systems for managing that. And the same thing pretty much happens with the iSCSI gateway, the existing iSCSI gateway that we have in RBD. Again, the gateway would have a coarse-grained entity, and you can sort of partition it into smaller entities on the outside with CHAP or whatever it's called in iSCSI. I'm not sure if integrating with CephX user management and in general, CephX authentication entities is a good idea, because we simply they're not used that way. All they do is control access to to Rados and not to individual RBD images, for example.
Yeah, I was thinking more of a use case where you're using. So if you want to use RBD images both through NVMe over Fabric and through either libRBD or kRBD simultaneously, you can't use the same access control mechanism because, and that, I mean, that's not optimal. You'll basically have to use both mechanisms simultaneously in some way. And basically you're saying that hasn't been done. There's no way that it's been synchronized in other cases. You use only one access method.
Yeah, because ultimately the libRBD instance, all it has is a single CephX entity. That's just how it works, and there is no around that. It has a single Rados messenger and a corresponding CephX entity, which that messenger then negotiates, gets the capabilities, gets the CephX tickets, which allow it then to talk to the OSDs and the rest of the cluster. So fundamentally, it's always a single CephX capability, and while you can have one per image, then that would mean that you would need to have that many libRados instances. And what we're doing here overall is we're moving to a single libRados instance with all those SPDK patches because multiple libRados instances just wouldn't work, wouldn't scale. So if you were to attempt to integrate with CephX or broadly speaking at a high level with Ceph user identities, that would mean that you would need a libRBD instance per such an identity. And that I imagine that again that goes counter to our scaling requirements.
Yeah, but yeah, I was more thinking of can we just have the gateway that SPDK be another enforcement point for the same policies that are actually within CephX, that are in the Ceph monitors, basically. So just view it as an access point. Naturally, because of what you said, because we want a single lib Rados client, the gateway needs access basically to all of the volumes it can mount. But can it serve as an external enforcement point to the same policies rather than having an entirely different set of policies?
Well, that might be possible to some degree, but yeah, it hasn't been done in other Ceph gateways, whether iSCSI or GW or anywhere else, as far as I know.
I'm just not sure how that would work because we're talking about like taking the Ceph security model and then having just random NVMe clients speak it, which would be a little strange.
Yeah, I mean you'll need the NVMe over Fabric to somehow use the same keyring notion as Ceph or something of that sort. I don't know, but yeah.
Maybe you could map it somehow, but the question is really what you gain by it, right? I mean, the only thing I could see is if you want to kind of harden it a bit, right? You could try to do something that you map a subsystem to a Ceph namespace and make sure that instead of having one libRBD context, you have one per subsystem. Then you don't have as much the scaling problem because you can have a lot of namespaces within a subsystem. But we have to see if that's kind of something we want to do, or if we just trust that whatever SPDK or let's say the NVMe spec puts out as authentication is good enough for us from a security point of view.
Yeah. Anyway, that was, I mean, I was thinking out loud, and there's no easy solution, at least from what I see.
Yeah, this is also something that was briefly mentioned last time by Jim, that the NVMe in-band authentication is not something that is being worked on yet, but that's probably also due to the fact that there's basically very little information in the spec. I mean, it is defined, but not to an extent where you could actually implement something. And there's a NVMe working group that works on the in-band authentication. If you're part of the NVMe working group, you can check it out. Unfortunately, all these things are apparently we are not allowed to tell them in public, but some of the details are mentioned there when it comes to how to do this in-band authentication. And that's probably one of the next things we also then need in SPDK to make this whole thing somewhat secure, right?
I think we're out of time, and Scott is not here to stop us, so we'll take action.
Yeah, unless everybody has something
Thanks,
else.
Okay. Thanks, folks.
Thanks all. See you next week.
Thank you. Bye-bye.
Bye.
Bye.